In topology, a branch of mathematics, the trefoil knot is the simplest example of a non-trivial knot. The trefoil can be obtained by joining together the two loose ends of a common overhand knot, resulting in a knotted loop. As the simplest knot, the trefoil is fundamental to the study of mathematical knot theory, which has diverse applications in topology, geometry, physics, chemistry and magic. The trefoil knot is named after the three-leaf clover plant. Descriptions. The trefoil knot can be defined as the curve obtained from the following parametric equations. The torus knot is also a trefoil knot. The following parametric equations give a torus knot lying on torus. Any continuous deformation of the curve above is also considered a trefoil knot. Specifically, any curve isotopic to a trefoil knot is also considered to be a trefoil. In addition, the mirror image of a trefoil knot is also considered to be a trefoil. In topology and knot theory, the trefoil is usually defined using a knot diagram instead of an explicit parametric equation. In algebraic geometry, the trefoil can also be obtained as the intersection in C2 of the unit 3 sphere S3 with the complex plane curve of zeros of the complex polynomial Z2 plus W3. If one end of a tape or belt is turned over 3 times and then pasted to the other, a trefoil knot results. Symmetry. The trefoil knot is chiral, in the sense that a trefoil knot can be distinguished from its own mirror image. The two resulting variants are known as the left-handed trefoil and the right-handed trefoil. It is not possible to deform a left-handed trefoil continuously into a right-handed trefoil, or vice versa. Though the trefoil knot is chiral, it is also invertible, meaning that there is no distinction between a counterclockwise-oriented trefoil and a clockwise-oriented trefoil. That is, the chirality of a trefoil depends only on the over and under crossings, not the orientation of the curve. Non-triviality. The trefoil knot is non-trivial, meaning that it is not possible to untie a trefoil knot in 3 dimensions without cutting it. From a mathematical point of view, this means that a trefoil knot is not isotopic to the unknot. In particular, there is no sequence of Reidemeister moves that will untie a trefoil. Proving this requires the construction of a knot invariant that distinguishes the trefoil from the unknot. The simplest such invariant is tricolorability. The trefoil is tricolorable, but the unknot is not. In addition, virtually every major knot polynomial distinguishes the trefoil from an unknot, as do most other strong knot invariants. Classification. In knot theory, the trefoil is the first non-trivial knot, and is the only knot with crossing number 3. It is a prime knot, and is listed as 31 in the Alexander-Briggs notation. The Dowker notation for the trefoil is 462, and the Conway notation for the trefoil is 3. The trefoil can be described as the torus knot. It is also the knot obtained by closing the braid sigma 13. The trefoil is an alternating knot. However, it is not a slice knot, meaning that it does not bound a smooth two-dimensional disk in the four-dimensional ball. One way to prove this is to note that its signature is not 0. Another proof is that its Alexander polynomial does not satisfy the Fox-Milnor condition. The trefoil is a fibered knot, meaning that its complement in is a fiber bundle over the circle. In the model of the trefoil as the set of pairs of complex numbers such that this fiber bundle has the Milnor map as its fibration, and a once punctured torus as its fiber surface. Since the knot complement is Seifert fibered with boundary, it has a horizontal incompressible surface. This is also the fiber of the Milnor map. Invariants. The Alexander polynomial of the trefoil knot is and the Conway polynomial is, the Jones polynomial is, and the Kaufman polynomial of the trefoil is. The knot group of the trefoil is given by the presentation, or equivalently this group is isomorphic to the braid group with 3 strands. Trefoils in religion and culture. As the simplest non-trivial knot, the trefoil is a common motif in iconography and the visual arts. For example, the common form of the Trikitra symbol is a trefoil, as are some versions of the Germanic Walnut. In modern art, the woodcut knots by M. C. Escher depicts 3 trefoil knots whose solid forms are twisted in different ways.